Good evening and welcome to the Q&A session 28 from the chapter of electric charges and fields. The topic is the electric dipole in an external electric field, and based on this topic I have one question for this session, and the question is: an electric dipole placed in an external uniform electric field of intensity 10 to the power 4 Newton per coulomb experiences a torque of 10 to the power 4 Newton meter when its dipole moment makes an angle of 30 degree with the direction of electric field. So, the work done in rotating this dipole from this position to its position of unstable equilibrium is. So, here we have to find the work done. So, in the session number 24 and 26, we have learned three important formulas. First one was the dipole moment, that is P is equal to 2A into Q. Now 2A is the separation between the two charges of an electric dipole. The torque acting on a electric dipole when it is placed in an external uniform electric field, that is equal to P sin theta. And the third important formula was, that is the work done in rotating a dipole when it is placed in a uniform electric field is equal to cos theta 1 minus cos theta 2. Now here theta 1 is the initial angle between the direction of the dipole moment and the direction of the electric field, and theta 2 is the final angle between the direction of the dipole moment and the direction of the electrical field. So this theta 2 is basically the angle after the rotation of the dipole. So from these three important formulas, we can easily find this work done. So here we have been given the intensity of the electrical field, which is equal to 10 to the power 4 Newton per coulomb. So I will be simply using this formula now. Here torque, we have been given the torque, we have been given the intensity of the electrical field, and we have been given the value of theta also. Theta is the angle made by the direction of the dipole moment with the direction of the electrical field. So this is equal to 30 degree. So torque is equal to 10 to the power 4 Newton meter, and this is equal to PE. P is the dipole moment, E is the intensity of the electrical field, which is equal to 10 to the power 4 Newton per coulomb, multiplied by sin theta. Now here theta is equal to 30 degrees, so sin theta will be equal to 1 by 2. So from here I can easily find the value of dipole moment, which is equal to 2 coulomb meter. So I am just writing the value of the dipole moment here on the top. That is, dipole moment is equal to 2 coulomb meter. Now we have to simply find the value of the work done in rotating this dipole from this initial position. The initial position is when the dipole moment is making an angle of 30 degree with the direction of the electrical field. So theta 1 will be equal to 30 degree, and theta 2 is what? It is the angle corresponding to the position of unstable equilibrium. Now in the case of unstable equilibrium, the angle theta will be equal to 180 degree. So the work done will be equal to P is equal to 2 coulomb meter, and the intensity of the electrical field is equal to 10 to the power 4 into, now cos theta 1 is equal to cos 30, which is equal to root 3 by 2, minus cos theta 2. Now theta 2 will be equal to 180 degrees, so cos 180 will be equal to minus 1, so this will be equal to plus 1, minus minus plus. So finally what I am getting here is, if I take the LCM, I will be getting root 3 plus 2. So the work done will be equal to root 3 plus 2 into 10 to the power 4 joules, or this can be written as, root 3 is equal to 1.732. So 1.732 plus 2 will be equal to 3.732 into 10 to the power 4 joules. So the correct answer here is the option A. So in this question we have utilized two important formulas pertaining to the torque which is acting on a dipole when it is placed in a uniform external electric field, and the work done in rotating the dipole from one position to another. So by using these two important formulas, we have been able to find the amount of work done in rotating this dipole from its initial position to the position of unstable equilibrium. So thank you very much again for joining this session. In the next session, I will be coming up with a different type of a question from the same topic of electric dipole. So till then, have a nice day. Bye.